Welcome to section 6.8, which is titled The Basics of Loans. Here we're going to look at loans that have monthly installments that are due, with the main focus on mortgages themselves, but our book does look at regular loans as well that take place for a shorter amount of time for less amount of principal because they all operate off of the same ideas. And so there's a couple of main ideas that will get us through the homework and that we'll present to you today as you watch this video. So one of the things that it focuses on and has us read from is an amortization table for a mortgage. So that's a big word, and amortization is basically the breakdown of all the payments that you're going to make. So what happens with any monthly installment loan is that we need to pay back the company what we borrowed, the principal, and also the interest. And we want to make a regular monthly payment, something that doesn't change from month to month, so that we always know what our obligation is and it doesn't change. And so we will be looking at fixed rate, types of loans that take place over the entire loan period. And so the question is going to be, well, how do I know how much to pay them so that both of those things take place? And then also in the very beginning, how do I calculate the interest owed at any given time? You got a glimpse of this in a previous section where we were making a prepayment to the loan. And as we made a small prepayment, it would have us calculate, well, how much actually went to the principal. And so very similar ideas happening there. So what I'd like to do is start out by having you look at an amortization table, just to highlight how interest plays a role. So let's take a look at this loan right here. We're going to take a $350,000 loan out for a house. It's going to be over 30 years, and the interest rate is 6.5%. You can see that in the little boxes that are towards the middle of your screen here. And so those are parameters that got put in, and it calculated this monthly payment, this $2,212.24. If I pay that every month for the next 30 years or 360 months, I will pay them back the $350,000 I borrowed from them and all the interest that I owed. What's amazing is how much interest accrues in that time. So take a look at the middle of the screen here where it talks about total payments. Over the life of this loan, you are going to make $796,404.04 worth of payments. Remember, we only borrowed $350,000, so that's an overage of $446,404.04. That's the interest that we owe. And so it's very common for the interest to be more than what you borrowed. Now, you can shave off some of that interest by maybe changing the terms. Maybe you're willing to pay it off in 15 years. Before I select 15 years, notice that my monthly payment is $2,212. Okay, and so as I select 15 years, something's going to change. And let's see if it will just recalculate. It did. It just recalculated. Now I have a $3,000 payment that I have to make. But the great part is, remember I was paying over $400,000 in interest? I now pay only $200,000. I cut my interest in half. And so if I can swing the $3,000 a month, it's definitely to my advantage. Often what happens too with 15-year mortgages is you get a less of an interest rate. It's not drastically less, but it is always less. So 6.0, let's put in there. And so a 6% interest. Now it's a slightly under $3,000, but look, now I'm paying only $181,000 in interest. At that original amount, it was over $400,000. And so I want you to look at an amortization table. So I'm going to select monthly and come down here, or no, actually come up here and hit view a report. This is month by month how much of your payment is going to principal and how much is going to interest. So notice as our first payment's made of $2,953 on this 15-year mortgage at 6% interest, right? So only a part of that, $1,203, goes to principal because I owe $1,750 in interest that month. And then notice that the interest amount keeps getting lower. Therefore, the amount going to principal keeps getting higher. this is the number of months, right? So here we are at the first year at the 12th month, and I'm still paying more in interest than I am to principal. And so we need to figure out, well, how do they know what that interest payment is? And how do they get that monthly payment so that I can know how much is going to principal? So as I keep scrolling down here, you can see at some point, where's that happening? Right here at year 44. I'm still making the same payment. It's interesting. It's allowing me to kind of log in here. So I make my 2,000 at number 44. Not sure why it's doing that. I make this payment. I have a $1,491 of it going to principal, $1,462 going to interest. So at that point, I'm paying more towards the house than I am to interest, and that continues. And if I go all the way down to the last part of the loan, you have such little money owed that you owe very little, or such little money of there's out that you owe such a little amount of money, where when you make the very last payment, the 180th payment, again, you're still paying the $2,953, but only a fraction of it, only $14.69 is going towards the interest, because you do not have a lot of their money out. And so we'll want to be able to read these reports, but most importantly, there's two goals, two main parts of the homework. Hey, how in the world did they come up with the monthly payment of $2,953.50 that would cover everything for the life of the loan? And how are they getting this interest? So as you look at this amortization table, it's important to realize that the bank is going to collect the bulk of its interest right up front. Okay, so let's go to some problems that we're going to have. So this is an amortization schedule that was in the book. Maybe I'll refer to it. I thought it was better. This one kind of chopped off some months and didn't go till the end. Here they're keeping track of the total interest paid as well, just so you can see that it gets higher and higher. But again, we want to know, where'd you come up with this $995.20? And where did you get that the interest owed that first month was $657.09? That's what we want to accomplish. So let's take a look at this loan right here. This loan, if we can see right at the top, was for a loan amount of $145,000. Let me scroll back up. $750. I needed to buy a home that was $145,750. The interest rate was 5.41%, and the number of years was 20. 20 years we're going to pay that thing off at. And so, again, this amortization table is kind of weird. It's a little choppy, but it was one that was found in the homework, so I just wanted to display it. It does share with us that the payment that's being made is $995.20, and it shows in that first month, I don't think I can highlight that, but in that first month, we had an interest owed of $657.09. Where'd they get that number? Well, let's get that number. So if we're going to calculate the interest owed, remember, interest has the variable I. It's very easy. Interest in any given month is equal to the principal that you still have out times the rate divided by 12. Now, why the rate divided by 12? Because the rate is an annual interest rate, and we have it for just 1 month. So the interest owed in that first month I'd never made a payment, so I still have $145,750 out of their money. Times the rate was 5.41%, so times 0.0541 divided by 12, and we'll hit equals. Let's run that number. I'm reaching down to get a calculator, so if my voice sounded a little distant, it's just because I didn't have the presence of mind to grab a calculator first. 145,750 times 0.0541 divided by 12 would be the interest I'm responsible for that month. They typically round interest up regardless. This one rounds up naturally. That's what came out. So the interest that I owe that first month, the interest part of the payment I'm going to make is $657.09. Notice that matches exactly with what I circled up there in red. Exactly what they thought would be an interest that month is what's there, $657.09. So your homework starts you out this way. As you start your homework, they're going to tell you, and I'm pausing for just a minute because I want to explain. So why are all of these numbers changing down the interest column? Right, as I look from 143, if I look here at that these two numbers right here, the values going to interest changed over those 2 months. And that's because the balances changed as well. When I go to calculate this one, it's off of this balance. When I go to calculate this one, it's off of that balance. We call this the remaining balance. So if I wanted to come up with what I owe in interest for month 148, I'd look at what I have outstanding right before that monthly payment is made. And that's the principle that I'm using. It's not off of the original 145,750. It's off of however much that is going down. That makes sense because once you go to the bottom of those tables, you get less and less going on there. Less and less principal owed. So here's what's going to happen. You're going to have a problem like number 8 in the homework. And it's going to tell you, hey, when you go to make a monthly payment, the remaining principal is equal to $78,913.76. You have an outstanding mortgage that only has 2.9% APR. Your interest rate is 2.9%. And the question is, calculate the interest due. Calculate the interest due this month as you make this payment. Well, interest is easy. It's the remaining principal times the rate divided by 12, right? Making that annual rate a monthly rate. Hey, what's my remaining principal? $78,913.76. What's my interest rate? 0.029, and then always divided by 12. And so we just take our 78,913.76, multiply that by 0.029, and divide that by 12. And as we do that, we get this number, 190.708. Let me go one more out. So what's the interest owed? 190.71 would be the interest owed that month. So whatever our monthly payment is, 190.71 of it's going to interest. The rest is going to pay down that principal so that it consistently changes over and over. So you're going to have a couple of questions like this in the homework where all they ask you to do is find the interest. Then you're going to have a series of questions that ask you to calculate the monthly payment. So if I go back up to my example, when we took a loan out for $145,750, let me come down here and write that. Our loan amount was $145,750, and the interest rate for that problem, I believe, was 5.41%. We'll go back up and double check. 5.41%. The number of years, it was for 20 years, right? Trying to keep that interest down, but our payments manageable. And we had a monthly payment for that. They came up with a monthly payment of $995. And the question is how'd they come? Oh, $995.20. Usually it's rare to see it be a perfect number. So $995.20. The question is, how did they come up with that number? Well, let's try it ourselves. There's a monthly payment formula. And so I think our book calls it PMT for payment. And it's big. It is P times R over N times 1 plus R over N to the NT, N times T. And on the bottom, it is 1 plus R over N to the nt minus 1. This is the formula that they have. There's one addition that I want to put in, and I want to highlight it by putting it in red. If I put in these parentheses right here, it makes it completely doable where I don't have to compartmentalize it in my calculator. I can just type it in as one big thing. So you know all of these symbols. Let's go ahead and plug in for what we have. So the payment for our loan, let's try to get this, how they came up with the $995.20. The payment is principal. Well, I know that's $145,750 times the rate, 0.0541, divided by the, it says divided by n. Let me change that n. N's always the same for us. When I wrote down the formula, I wrote down the general one. N is always 12. These are monthly payments in everything we do. So these should all be 12s in there. All divided by 12 times 1 plus 0.0541 divided by 12 to the 12 times 20. And on the bottom here, the big parentheses on the outside, 1 plus R, we know what R is, 0.0541 divided by 12 to the 12 times 20, minus 1, close the parentheses. So you know what I'm going to ask you to do next. What I'm going to ask you to do next is figure out what 12 times 20 is and write it down. So on our calculator, if we do 12 times 20, we'll get 240. So we're going to come in here and replace our 12 times 20s, and I'll put it in blue to highlight it, 240 would be what we would do before we ever put this into our calculator. Now we should be able to put it in our calculator exactly how we read it. So we'll give it a shot and see what happens. 145,750, open parentheses, 0.0541, divided by 12, close parentheses, open parentheses, 1 plus 0.0541, divided by 12, close parentheses, raised to the 240, and then we're going to divide by, because of the fraction bar, open parentheses for this one right here, another open parentheses for the 1 plus 0.0541 divided by 12, close the parentheses, raised to the 240, subtract 1, close the parentheses. And we hit equals. And look what comes out, 995.201, and it just keeps going. That is where they got the payment, $995.20. Again, I spoke it when I put it in, but I typed it in just like I saw it here. No differences whatsoever. The only thing that's not displayed is that the fraction bars are division, right? So as I run across them, I just do a big divide. This is what they're going to have you practice for a majority of the problems, and that is to just calculate the payments. So if I grab one like number, let's get one that's a little bit different. Let's look at number 12. And in number 12, I'll switch back to the black pen. In number 12 in the homework, they want you to take a loan out. They call it the principal is equal to 11,870. The annual interest rate is what they type out, and that is given to be 3.59%. And this is for 3 years. So this is like a car loan, right? But one where they want to structure it where they capture that interest early. Well, we know the payment formula. The payment formula is equal to P times R over N times 1 plus R, I apologize, not N, 12. 1 plus R over 12 to the 12 times T, all divided by 1 plus R over 12 to the 12T minus 1. Right? That's our formula right up here. And you won't need to memorize it. You can bring it with you to the test. So P, 11,870. R, well, they gave me R. R is 3.59%, so 0.0359, all divided by 12, always. Open parentheses, 1 plus 0.0359, all over 12. All to the 12 times 3, for emphasis. And now we have 1 plus 0.0359, all over 12, to the 12 times 3, minus 1. What's left? Well, what's next is you can either rewrite it, or you could come in here and say, you know what? Let me highlight that again. I'll put it in red. Hey, this is 36. This is 36. Do that, because it's less. If I don't have you do that, you have to be super, 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 super careful plugging it in. But now you can just plug it in the way you see it. So what am I plugging in? I'll write it as I type it. I'm plugging in 11,870. Okay, so I'm plugging in 11,870. Just typing in open parentheses, 0.0359 divided by 12, and close the parentheses. 0.0359 divided by 12, close those parentheses. Open parentheses, 1 plus 0.0359 divided by, close the parentheses. Raised to the 36. And then divide by, oh, and let me fix my formula. I need these outside parentheses. Divide by open parentheses, another open parentheses, 1 plus 0.0359 divided by 12, close the parentheses, to the 36. And then minus 1, and close the parentheses. And your calculator knows exactly what to do with that. And you get a payment that seems reasonable. $348.288. So $348.29 would be the monthly payment you should make in order to pay back the company in the next 3 years, $11,870, and pay them both that back and the interest. It's that nice. So you just get some familiarity using that, what appears to be big formula, but it works out to be super, super, super nice. Okay. The next thing that they're going to do is give you an amortization table and ask you some questions about it. So that's why I did this table right here, right? So if I go back into this table, don't know if it will let me erase some of my marks from earlier. Let's see. Or if it kept them. It kept them. So I apologize for the red marks in there. But they're going to give you an amortization schedule. It looks just like this. And they're going to say, how much was the loan for? And you're going to answer, oh, $145,750, right? Is what you're going to say about that. Let me get a highlighter here. But how much did you take the loan out for? Took the loan out for $145,750. They'll ask you for what the interest rate was. Oh, 5.41%. They'll ask you for the length of the term, 20 years. They'll ask you, hey, how much went to principal for payment 137? So you'd find payment 137. You'd say, oh, well, out of my $995.20 payment, 623 of it went to principal. That's pretty awesome, right? So a majority of it went to that. They'll ask you, hey, what's your monthly payment? And you'll say, well, it's $995.20. It's right up here, right? Up at the top. So the last questions that you're going to do are just going to be about reading the table to make sure you're understanding the information. I think it's nice that it somewhat finishes there. There's some questions later on about total cost of the loan, but those, you'll see those. They'll make sense. You're basically just adding up numbers that they're giving you. But the big process is going to be calculating the interest for any given payment, the interest owed at that billing period, and then also calculating the monthly payment. That's where a majority of your time is going to be spent, and you'll do really well. Trust the formulas and trust yourself. Reach out if you have any questions or concerns. Thank you so much for watching the video.